So welcome back to our next lesson. Again, we're still comparing and ordering rational numbers. We just want to do a few more examples. This is going to be lesson 1B. In this lesson, we want to order the following fractions from least to greatest. So we want to order the following fractions from least to greatest. Some of the steps in doing that, to order fractions, it's easier to order fractions if we have a common denominator. It's like comparing apples to apples. It's a lot easier if we have that same denominator. It makes more meaning come from the problem. So once we find the LCD, what we're going to do is rename these fractions to equivalent fractions so that they do have indeed a common denominator. And then from there, we're going to be able to order these fractions rather easily. Now going across there, I mean, at a glance, 3 out of 4, or 3/4, notice that it takes 4/4 to be a whole. So 3/4 should be less than 1. 1 over 1 is the same thing as 1. 1/3 kind of means 1 out of 3. So again, it takes 3/3 to be a whole. So 1/3 is a lot smaller than 1. 3/8, again, it takes 8/8 to be a whole. So 3/8 is going to be a lot smaller than 1. 1/4, again, it takes 4/4 to be a whole. So 1/4 is going to be smaller. Then we have this 1/2, and then we have this 5/8. So right now, just by observation, I know that 1 is really the biggest fraction, should be on the end. I know that 3/4 is more than 1/4, just through my experiences. And half is probably going to be bigger than some of these others, but to keep it a little bit more consistent, what we'll do is just focus on getting a common denominator. And to get a common denominator, all you really have to do is focus on the multiples of the numbers. And what I'm going to do is, I wrote the different denominators down. So I had 1 as a denominator, 2 as a denominator, 3 as a denominator, and then 4 and then 8 with the different denominators. What I want to do is actually focus on the largest denominator first. So I have 8. I could go and get 16 there. But notice how that 8 is kind of growing rather quickly. So I'm kind of backing off that now. I'm going to go down to the 4. 4, I have 4 or 8. Notice how now I have a common denominator between those. Now if I go to the 3, I have 3, 6, 9, 12. So notice again, I don't have a common denominator at this point. So I can kind of keep building. 4, 8, 12. Those match up, but notice that the 16 doesn't. So it looks like the 18 is going to have to keep being built. So the next multiple of 18 would be a multiple of 8. So the next multiple of 8 would be 24. So if I keep building these out, kind of playing with them, 4, 8, 12, 16, 20, 24. That matches up. 3, 6, 9, 15, 18, 21, 24, that matches up. And I'm kind of saying, well, 2 also have a factor of a multiple of 24. And 2 would be a multiple of 24, I believe. We have to go out of the ways. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So it would be out there. 1, again, I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Multiples of 1 would be, like I said, 1, 2, 3, 4. And clearly 24 times 1 is a multiple of 1. So what it looks like is this 24 becomes our common denominator. So you're looking for a number that matches them in common here. So if you lay this work out, it's going to make it a little bit more clean. So what I'm going to do is come across here and change all my denominators to 24s. But now that I've got all my common denominators, I now have to rename my fractions to equivalent fractions. So to make these equivalent fractions, I have to pay attention how did a 4 actually change into a 24? If I look over here, it took 1, 2, 3, 4, 5. It took 6 4s to make 24. So what I essentially did is I multiplied the 4 by 6, but if I do that, I also got to multiply the 3 by 6. And therefore, that changes into 18 24ths. To get a 24, I recognize for a 1 to be a 24, I had to multiply the bottom by 24, but also I had to multiply the top by 24. So this becomes then 24 24ths. Looking at that 1/3, that 3, it took 1, 2, 3, 4, 5, 6, 7, 8 3s to give me a 24. So that means I had to multiply the bottom by an 8, but to keep it equivalent, I'd have to also multiply the top by an 8. So that would give me then 8 24ths. 1 times 8 would be 8, 3 times 8 is 24. And this looks very similar, because if 3 times 8 is 24, then that means 8 times 3 was 24. 1, 2, yeah, there's 3 8s gave me 24. I have to multiply the top of there by 3, and that would give me then 9 24ths. That 1/4 again, it took 6 4s. If I multiply that by 6, I've got to multiply that by 6. That changes to 6 24ths. A half took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 2s to get 24. Or if we know 2 times 12 is 24, I multiply the top by 12, and I get my 12 24ths. We took, again, 3 8s to get 24, so that changes to 15 24ths. Now that these all have the same common denominator, we're allowed to come through here and just organize them again. It was smallest to largest. So at this point, since all the denominators are the same, all I have to focus on are my numerators. So I'm looking for the smallest numerator. It looks like this 6 24ths is the smallest one. So that 6 24ths comes down. So I've kind of done him. Now I have the, looks like the 8 24ths is next. So he's gone. 9 24ths will be next. Looks like 12 24ths would be next. 15 24ths. So we use that one. And then we have 18 24ths. And then we had 24 24ths. So that would be organized from least to greatest. But again, we still got to put them back into the original form. So that 6 24ths corresponded to 1/4. So 1/4 was actually the smallest fraction. The 8 24ths corresponded to that 1/3. 9 24ths corresponded to 3 8ths. 12 24ths was the half. 15 24ths was the 5 8ths. 18 24ths was the 3/4. And then the 24 24ths was the 1/1. So it takes a little bit doing. You notice that an organized pattern here really can help keep your math going along smoothly. So notice how, again, we kind of kept it nice and organized here. So hopefully this will help you in comparing and ordering fractions here. So stay tuned.